Welcome everyone. So this is a MAT-243 workshop. I will be hosting this workshop every Tuesday at 8 for the rest of this term. My name is Ramya. I am the IT coach here at SNHU. I was previously an adjunct professor and I like to cook, hike, and paint. So in tonight's workshop, we're going to be reviewing definitions in descriptive statistics. We'll get familiar with some Python commands for descriptive statistics. And we'll learn about probability and some rules in probability. As we get through this workshop, feel free to use the chat box. Any comments, any questions, please use the chat box. I will be looking at the chat box and I will answer your questions as we go. So feel free to stop me, ask me any questions that you would want me to answer. All right. Because this can be interacting. It doesn't have to be just me talking. So feel free to jump in. All right. Let's get started with what is statistics. So it is a branch of mathematics that transforms data into useful information. And there are two types of statistics, the descriptive and the inferential. The first few weeks in your course, we are going to be focusing on descriptive statistics. But from the third week onwards, we will be doing inferential statistics. So what's the difference between the two? Descriptive statistics is collecting, summarizing, and describing the data. For example, if I'm running a survey and I get, let's say, the height of all the people in a sample. Let's say I have a sample of 100 people and I find their heights, and then I'm taking the mean of their height. So that is my sample, and I'm taking the mean. So that is descriptive statistics, where I'm just collecting my data. Inferential statistics would be to conclude something about the population based on your sample. So if based on my sample results, if I can predict what is going to be the mean height of all the people in a particular state, that would be inferential statistics. We'll do a little bit more about that when we get there. But for now, we will be doing descriptive statistics for the first couple of weeks. And yes, I will show you the discussion post towards the end. I enter some sample data and I will show you how that would be. So just hold on to your questions till we get to the discussion post. So let's look at some definitions first. So population, any collection of objects, people, or things on which a study is conducted. For example, women between the ages 18 and 35, all gym goers, etc. What's a sampling unit? It's an individual in the population on which a measurement can be taken. A sample is a collection of sampling units that provide data to be collected. So you can see in the picture here, I have a population. One person from this population will be the sampling unit, and a group of such people will be the sample. Surveys are conducted to retrieve information from a sample. And statistic, it's the numerical characteristic of a sample or a single measure of some attribute of a sample. For example, the mean, the median, the mode, these are all statistics. This presentation will be available to you. I'm recording it, so I will be sending you this recorded presentation and not a static recording. But just make sure you enter your email address in the box, otherwise I will not know whom to send it to. So sampling methods. What are the different sampling methods? There are 5 of them. Simple random sampling. In this kind of sampling, a random selection is made from the population. There is no particular order in which people are selected for the survey. It's just a random selection. Systematic sampling. Every kth unit from a population of n units is selected. For example, every third customer, every other woman, every third house. So there is an order here. There is a system that we are following. So this kind of a sampling is called systematic sampling. Stratified sampling. Population is divided into groups based on a characteristic. Samples within each stratum are selected in a proportional manner. For example, grouping people by age and selecting 5 from each group. Let's say, for example, we want to find out what's the mean number of people who like ice cream. And let's say I have a sample, I have a population, and I divide that into different age groups. I have 0 to 15, 15 to 30, 30 to 45, 45 to 60, and above 60. So if I have these many stratums or these many groups, I can select some people from every group in a systematic way. Let's say I decide to choose like 5 people from every group. That would be stratified sampling. Cluster sampling, on the other hand, is very similar to stratified, except that here I'll be selecting the entire group and not few people from every group. So if I'm trying to group people by age, and let's say I select all the people above 60, so that is cluster sampling, where my entire group is selected. Convenience sampling. Units are drawn from a subset of the population that's readily available. So for example, people at a train station, outside a grocery store. This kind of sampling is done when you don't have the time or the budget to do any other kind of sampling. Then you just go to the nearest convenient place and take the survey. Measures of center. So the mean, the median, and the mode are the measures of center. So what's the mean? It's the sum of the data values in a data set divided by the number of values in the data set. And how do we find the mean? We add up all the values in the data set and then we divide it by the total number of values. The median is the middle value in a sorted data set. When I say sorted, it should be in ascending or in descending order. And then we take the middle value, that's the median. The mode is the most frequently occurring value in a data set. So what would be the Python code to do this? So we have to first import the Pandas library. The Pandas library, it's also called the Python Data Analysis Library. It's one of the most preferred modules or libraries that we can use for statistical computations. So you will see as we go through the course, we will be using Pandas very often. Then we have a variable called scores. We say scores equals pd.read_csv. So what we are doing here is we have a text file called exam scores. And all the data from the text file is being saved in the variable scores. Then if we do print scores.mean, it will give us the mean of all the scores. Print scores.median will give the median, and print scores.mode will give us the mode. Let's do an example by hand, and then I will show you an example in Trinket. So here I have an example. I have some numbers, and the mean of those numbers is 6. So how did I get the number 6? You add up all the numbers, then you divide by the total number of values. So here I have 3, 6, 7 values. So when I add up all the values, I will get 42 divided by 7. So the mean would be 6. Okay, now I have the sorted data set. So this is in ascending order. If I ask you, what is the median of this data set? Can you tell me what the median is? Great. Very good. So the median is the middle value. So because we have 7 values, the middle value is the 5. And I have 3 to the left and 3 to the right. So 5 is my median. But if I had even number of values in my data set, then there will be 2 middle numbers. And if you have 2 middle numbers, in order to find the median, you have to find the average of the 2 numbers. So just add up the 2 middle numbers divided by 2. That will be the median. And then let's find the mode. What will be the mode of this data set? Mode or modes? Yeah, there are 2 modes here because there are 2 numbers which occur twice, 5 and 10. So 5 and 10 are the modes. It's possible to have more than one mode. It doesn't have to be one in any data set. In this case, we have 2. It could be more than that. So this is a screenshot of Trinket where I have a text file and then I find the mean, the median, and the mode. There is no limit to the number of modes that can be in a data set. So it's the number or the numbers that occur the maximum number of times. So whichever number occurs the maximum number of times, that will be the mode. So let me quickly show this to you in Trinket. I'm going to stop sharing, so your screen is going to turn blank for a second. Okay, I hope everyone can see my screen. I'm sorry the font is really small. If it is too small for you to read, there is a button on the top right, not all the way to the right, just on the screen that you see on the top right, there is a button that looks like 4 arrows pointing in 4 different directions. If you click on that, it will change to a full screen mode. So here I have a text file. You can see I have 4 exam scores. And I'm going to find the mean, the median, and the mode for these exam scores. So here, the lines that we need to look at are from line number 5 to line number 15. So I have the same code that we just looked at, importing pandas, then scores equals pd dot read underscore csv. Then I have 2 print statements, the mean is, and then printing scores dot mean. Similarly for median and for mode. So if I run this, for some reason it was not running this evening when I tried it. I'm not sure if Trinket is slow. Yeah, it's really not displaying the output for some reason. But it's good I have the screenshot. So you can see, I will show it to you that when you run this code, you will get the mean for every exam. So if I have 4 exams, it will give me the mean for each of the 4. Similarly with the median and also the mode. I'm going to try one more time. Sometimes it takes a while, but today it's been taking an awfully long time. Maybe it's not working. The other two inputs, no, not now. So don't worry about the other. I just have those in there. So when I need to run it, I don't have to import anything. But for now, all you need is the pandas. Yeah, it is imported twice. So just ignore that. The first 3 lines, I just have it in there all the time. Yeah, kind of. All right, I'm sorry. This trinket isn't really giving me any output tonight. Okay. I'm just going to go back. If there is time, I'll come back in the end and show you all of these. But these examples are there in Zybooks. Though the text file could be a different one, I chose a smaller text file just to show you smaller piece of numbers. But in Zybooks, whenever you see the blue box with the Python code, below that you will see the run example. So if you click on run example, it will take you to Trinket. You can run the code, you can see the output, also make some changes and see how your output changes. So I'm going to go back to the PowerPoint. Okay, so this is how it would be if I had been able to run that. You can copy the code and run it in Python 3. If you have Python in your computer, you can run it, but you need to have the text file. So check in Zybooks if you are able to download the file that is associated with the code. If you're able to download it, then I think you should be all set. You can run it in your computers if you're having Python. Otherwise, you can always play around. Just create your own text file with some numbers in it, and then use the same code, and you should be able to run it. Okay. Measures of spread. Oh, okay. That's good to know. Yes, I've had no issues with running floats. So what's the spread? The spread is a measure of how spread out or how dispersed or how scattered your values are in a data set. If all the values in a data set are clustered close to the mean, then we say the spread is very small. But if you have values which are scattered, which are spread out, which are far away from the mean, then we say the spread is more. And the way we find the spread is usually find the difference between the values in the data set and the mean of the data set. So there is a formula. We can take a look at that. The first measure of spread that we're going to look at is standard deviation. So standard deviation is a measure of the distance between the data values and the mean of the values. So there's a formula. Standard deviation of a population is given by sigma. Sigma equals square root of summation I equals 1 through n, ai minus mu squared over n. Ai is your individual values in your data set. Mu is the mean of the data set. So we can do an example. So here I have the same set of numbers that we just looked at, and the mean was 6. So how do we find the standard deviation? Here I'm using S instead of sigma because this is a sample. This is not the entire population. For a sample, the standard deviation is given as S. So I'm saying S equals square root of, how did I get these numbers? So what I want to do is pick one value at a time from my data set, subtract the mean, which is 6, and square it. So my first value was 2, I subtracted 6 and I squared it. That's the first term that I get in the numerator. Second value is 3, subtract the mean and square that. So you go on doing this for all the numbers, then add all of them and divide by n minus 1. This n minus 1 is the sample size, which was 7, 7 minus 1. So my value is square root of 10, which is 3.16. So what's the Python code? We import pandas as PD. Again, we have scores equals pd dot read underscore csv. So the first two lines might be familiar to you now. Now you just do print scores dot std. Scores dot std will give you the standard deviation. Sorry. What's the other measure of spread? It's the variance. The variance is nothing but the standard deviation squared. So if you know the standard deviation, you just square that, you should get the variance. So if my standard deviation is square root of 10, if I square that, I get 10. That's my variance. Python code, you import the pandas, and then you do print scores.var. So here I don't have the line which says scores equals pd.read underscore csv, but you still need to do that. Okay. This is again screenshot from Trinket, where I'm finding the standard deviation and the variance. So for each of the 4 exams, you can see you will have the standard deviation and then the variance. Any questions so far before I move on to the minimum, maximum, and range? So the minimum, maximum, and range for a data set, it's pretty straightforward. The minimum is the smallest value. Will you be writing any code? For your projects, you would have to write a small part of the code, but don't worry about that. There will be guidelines for you to follow. So you will not be asked to come up with an entire project where you have to write everything from scratch. It's not going to be like that. If you have seen your discussion, how it is, so it's broken up into different parts. Every part, they give you an explanation and they tell you what to do. In the first discussion, I think you just have to enter the temperatures. The rest of it is all there. But in your projects, you will have to write a few things here and there, like you will have to replace some variables with the right one, put in the right values, things like that. But there will not be any full-fledged hard coding. In your project, there will be one part which you would have to code, but as I said, there will be guidelines for you and your professors. You can take your professor's help, or you can book a one-on-one session with me or with me, IT peer tutor. We can help you out with that. But for the most part, it will not be any kind of a heavy hard coding stuff. So, and you should be able to do it. So don't worry too much about it. Yes, kind of just adjusting the code here and there. So the minimum value is the smallest value, the maximum is the largest value. The range will be the difference between the two. So if you look at the Python code, scores.min would give us the minimum value. print scores.max will give the maximum value, and print scores dot. So for the range, you don't have scores.range, sorry. For the range, what you have to do is you have to actually go and manually find the difference. So you have to write the code to find the difference. You do the scores.max minus the scores.min, and then just print that value. So there is no function to actually find the range. Yes, you set up any variable for the range and just find the difference between the maximum and minimum. So here is an example, small data set. What's the minimum, the maximum, and the range? This shouldn't take too long. So quickly tell me what's the minimum, the maximum, and the range. Okay, 48, 480, and 76. Great. Next, let's look at quartiles. Before I read through what's there, I want you to take a look at the data set that we have. If you'll see closely, the middle value or the median of the data set is 8. So I have 4 values to the left, 4 values to the right. So 8 is my median. The median is also called the second quartile or the 50th percentile, because half the values are below the mean, half the values are above the mean. So it's the 50th percentile. So in general, when we talk about percentile, any percentile value is such that that number of percent of the data will lie above or below it. Sorry, at or below it. So here, when I say 50th percentile, I have 50% of the values below it. So it's called the 50th percentile. Then if you see, I have something marked as Q1. That's my first quartile or the 25th percentile. What I have done is taken the lower half of my data and I found the median of the lower half. So my lower half had 4 values. I had to find the median. So the middle 2 values were 4 and 5. So I found the average of 4 and 5. So my 25th percentile is 4.5. What does this mean? This means that 25% of my data will lie at or below this number. Similarly, I've done the same thing for the upper half of the data. I found the median of the upper half. The upper half, there were 4 values. So if I had to find the median, I had to find the average of 16 and 58. And the average of 16 and 58 was 37. So that's my third quartile or the 75th percentile. And it's called the 75th percentile because 75% of all the data lie at or below this value. So now if you read through what's there in the table, it's pretty much the same thing. So the first quartile is marked as Q1. It's the 25th percentile. 1/4 of the data fall at or below Q1. It is the median of the lower half of the data. Second quartile is Q2, the 50th percentile. It's the median. Third quartile is Q3, 75th percentile. 3/4 of the data fall at or below Q3. So it is the median of the upper half of the data. So if we have to do this in Python, the code would be print scores.describe. So describe is the function that will give us a lot of information. It will give us the minimum, the maximum, the first quartile, second quartile, the third quartile. So here's the screenshot. This is for the minimum, maximum, and range. And then this is for the describe function. So if you see in the output on the right, so it gives us a lot of information. It tells you how many values are there in each. So for exam 1, the first one that it says count, that's the number of values that are there in that column. So for exam 1, there were 5 values. And then it gives the mean, then the standard deviation, the minimum, then the 3 percentile values, and then the maximum. So all of these can be found out by just using the describe function. Does anybody have questions before we move on? Yeah, it's a very helpful function. Yes, for the describe, these will be the outputs. Yeah, I agree. Just one function does everything. Okay, Boxplot. So Boxplot is a plot that we do making use of 5 numbers from our data set. The values are the minimum, the 3 quartiles, and the maximum. So here is an example of a box plot. Let me just tell you what it actually means. So as you can see, there is a rectangular box, and there are 2 lines, on the one at the top and one at the bottom. These are called the whiskers. So the line that extends to the bottom all the way down, the line would extend up to the minimum value in your data set. The line on top would extend up to the maximum value in your data set. So if you mark the 2 points, those are the minimum and the maximum. The rectangular box, the lower end of the rectangular box is the first quartile. Then you mark the median. And then the upper end of the rectangular box is the third quartile. So just looking at the box plot can give us a lot of information about the data set, the minimum, the maximum, what's the median, where are the quartiles. So the box plot comes in very handy when you want to actually compare different columns of a data set, or let's say different data sets. For example, I have one here from Zybooks. So this whole thing is from Zybooks. They have a file which is examscores.csv, and then they construct a box plot with all the values from that file. And you can see there are 4 different exam scores, and for each of the exam scores you get a plot. So it's very easy to compare different data sets. One thing that I would like to suggest is, as you're reading through, if you're having a lot of Python functions that you want to remember, just make a note of those. Keep some notes so you can refer to it. Because sometimes it might be hard. As we go forward, there'll be a lot of Python code, and sometimes you'll have to go back and search for code because you would need that to get some results. For example, we'll be finding the probabilities of getting a value greater than or less than some value. So then you would have to actually refer back to a different module and get the Python function. So if you can have some notes where you keep noting down the Python functions, it will be very easy for you to refer to it. And also for the quiz, I think there is a quiz that you'll have to take for the Python functions. So if you have all the Python functions, you can just read through that before the quiz and then take your quiz. It will be very helpful to you. Okay, next is probability and counting. Before I start probability, does anybody have any questions on what we have done so far? Okay, this first module, I know there is a lot of reading material. Make sure you read through all of them because it provides a very good foundation for what's going to come in the next few weeks. But as we go forward, you will see you may not have these many sections to read from next week, but the first week, just make sure you take the time to read through all of it. And I've done my best. I tried to pick all the important things. One second, what was the question? Okay, on the last slide for the box plot. So what we have to do for the box plot is, if you see on top, the first few lines, you are importing a lot of modules. You are importing the matplotlib.pyplot, which is very similar to MATLAB. It helps to create a plot. Then we're importing the Seabourn, which is also a very, very important library. The Seabourn is imported as SNS. What does this mean? Anytime I want to use some function from the Seabourn module, what I would do is use SNS instead of typing Seabourn every time. I just have to type SNS. The same thing applies for Pandas library. When we import it, we say import pandas as PD. So Python will know that whenever you say PD, it means pandas. And same thing applies for the matplotlib.pyplot that has been imported as PLT. So you can see in the last line, we're using the show function. So we do plt.show. Yes, that's right. Any other questions? All right, let's start with probability then. Look at some definitions first. Experiment. It's a procedure that results in one out of a number of possible outcomes. For example, rolling a six-sided die is an experiment. Outcome, that's the result of an experiment. So if you roll a six-sided die, that's the experiment, and the number of dots that's displayed is the outcome. Sample space, it's a set of all possible outcomes denoted as S. The sample space of a six-sided die roll is S equals, so we use the braces, the curly brackets, and we write all the values that we can possibly get if we roll a die. So the numbers 1 through 6 will be your sample space. Event, it's a subset of the sample space. For a die roll, the event A is rolling an even number. The event A is equal to 2, 4, or 6. It's a subset of the sample space 1, 2, 3, 4, 5, 6. So there are two kinds of events. One is simple and the other is compound. So the simple event is a subset of a sample space with a single outcome. So the event C is rolling a 5 on the die, then C equals 5 is a simple event because you have only one outcome here. But if we had more than one, then we call it a compound event. For example, if event A is rolling an even number on a die, then A would be 2, 4, 6. So that's a compound event because you have many outcomes here. Probability. So probability is a measure of how likely an event is to occur. The probability of an event A is denoted P of A, and it is a sum of the probabilities of each outcome in the event. So here's an example. If a six-sided die is being rolled, what is the probability of getting an even number as outcome? So I have my sample space. So sample space is all possible outcomes. When you roll a die, the possible outcomes are numbers 1 through 6. So that's my sample space. Since every outcome is equally likely, the probability of each number is 1 over 6. So because we have 6 outcomes, the probability of getting any number would be 1 over 6. So the probability of getting an even number would be the probability of getting a 2 plus the probability of getting a 4 plus the probability of getting a 6. And we know that the probability of every number is 1 over 6. So we just add the 3. 1 over 6 plus 1 over 6 plus 1 over 6. So that would be 3 over 6 or 1 over 2. So the probability of getting a number is 1 over 2. Events as sets. A six-sided die is rolled. Let A be the event. A number less than 4 is rolled. Let B be the event. An odd number is rolled. Construct the Venn diagram for these events. So a Venn diagram, it consists of a box as shown here, a rectangular box, and then you'll have 2 or 3, you can have more than that, many circles. So depending upon what different outcomes you can have that many circles here. So here I have one circle for the outcome A, and B is the other circle for outcome B. So my sample space is 1 through 6. A is equal to 1, 2, and 3 because A is the event that a number less than 4 is rolled. So the numbers less than 4 are 1, 2, and 3. So what we do is we draw 2 circles, and the 2 circles overlap. That's because there are some values which are common to both the circles. So B is the event that an odd number is rolled. So the odd numbers are 1, 3, and 5. So if you compare A and B, you see the numbers 1 and 3 are common to both. So when we draw the circles, we overlap them, and in the middle part we write 1 and 3. And then the remaining values are written in the respective circles. So for A we have 2, for B we have 5. And then there are 2 more values in the sample space which are not included in these outcomes. Those are 4 and 6. So those would be outside of the 2 circles, but inside the rectangular box. So this is a Venn diagram. What is A union B? The symbol is a U for union. So the union of 2 sets or 2 events A and B is denoted A union B, and is the event that includes outcomes in A or B or both. So you have to take both the circles into consideration and include all the values from both the circles. So A union B, you have to combine them. So it will be 1, 2, 3, and 5. What is A complement? So I have an A on top, I have a bar, so that's called A complement. So A complement of an event A is denoted as A bar and is the event consisting of outcomes that are not in A. So if we take only the A circle into consideration, I have the numbers 1, 2, and 3. All other numbers are not in A. So A bar, or the complement of A, would be all those numbers which are not in the circle. So 4, 5, and 6 will be the complement of A. We can also similarly find B complement. What is A intersection B? The intersection of two events A and B is denoted A intersection B and is the event consisting of outcomes that are in both A and B. So you have to include values that are common to both. So that would be the middle overlapping part in our Venn diagram. So it includes the values 1 and 3. So those are the values that are common to both A and B. So A intersection B, so the intersection symbol is an inverted U. So A intersection B would be 1, 3. Does anybody have questions? Mutually exclusive events. Two events A and B are mutually exclusive if A intersection B is the null set. I'm sorry that the symbol is not too clear. So it's like the 0 with a kind of a stroke over it. So that's called the null set. That is, A and B have no outcomes in common. For example, a coin is tossed. The event of the coin coming up with heads and the event of the coin coming up tails are mutually exclusive because the coin cannot come up with both heads and tails at the same time. So mutually exclusive events will be those where you don't have anything where if one occurs, the other event cannot occur. So that would be mutually exclusive. So when a coin is tossed, you can either get heads or you can get tails. You cannot have both of them. So for example, a 6-sided die is rolled. A is the event of getting a number greater than 4. B is the event of getting an even number. And C is the event of getting a number less than 5. All right, my slideshow didn't work, so the answers came up. But I want you to think about why the answers are the way it is. So are events A and B mutually exclusive? So let's look at it. A is the event of getting a number greater than 4. So that would be 5 and 6. B is the event of getting an even number. So those would be 2, 4, and 6. So are the events A and B mutually exclusive? So if they were mutually exclusive, they would not have anything in common. But they do have some values in common. So at least 6 is the value that is common to both. So they are not mutually exclusive. Are events A and C mutually exclusive? So let's look at it. C is the event of getting a number less than 5. So that would be 1, 2, 3, and 4. And A is the event of getting a number greater than 4. So that would be 5 and 6. So there's nothing common between the two. So they are mutually exclusive. Are events B and C mutually exclusive? So B is the event of getting an even number. That will be 2, 4, or 6. C is the event of getting a number less than 5. So that does include 2 and 4. So B and C, they are not mutually exclusive. So if I have A and B as two mutually exclusive events, then we have some axioms or some rules of probability. And what are they? The probability of any event is always between 0 and 1. So here we've given an example. We're saying probability of P of A, probability that event A occurs is between 0 and 1. The probability of the sample space is 1. If you include all the values in your sample space, if you add up all the probabilities, it's always 1. Probability of P A union B would be P of A plus P of B. So it's the probability of event A occurring plus the probability of event B occurring. So you have to add them up to find the union. So what's the complement rule? For any event A, if the probability of A is P of A, the probability of A complement is P of A bar equals 1 minus P of A. So because all probabilities add up to a 1, so if I have P of A, if I have the probability of event A occurring, the probability of event A not occurring would be 1 minus the probability of A occurring. So it's 1 minus P of A. Then we have the addition rule. For any events A and B, P of A union B is P of A plus P of B minus P of A intersection B. For mutually exclusive events, if you notice, the third term, P of A intersection B, will be 0 because there is nothing common to the two events. So then you would come back to this axiom, which is P of A union B equals P of A plus P of B. Independent events and the multiplication rule. So two events are independent if the probability of one event does not affect the probability of the other. A coin is flipped and a six-sided die is rolled separately. Let A be the event of getting tails with the coin, B be the event of getting a number less than 3 with the die. So A and B are independent events. Because the probability of one thing happening does not affect the probability of the other thing happening. The multiplication rule. The multiplication rule gives the probability of two independent events happening together. If A and B be independent events, the probability that both A and B will occur is P of A intersection B is P of A times P of B. So in independent events, what happens is there is something, both events can occur. One does not affect the other. For example, if I'm tossing a coin, if I toss the coin just once, then the event of getting a heads, if I calculate the probability of getting a heads and the probability of getting the tails, I can either get the heads or the tails. I cannot have both, right? So they are mutually exclusive. But if I'm tossing the coin 2 times, and I'm trying to find probability of getting heads in the first toss versus the probability of finding let's see again a heads in the second toss. Both are different, both are independent. My one toss does not affect my other toss. And because they are different, they don't affect each other, we call them independent. So when I send you the follow-up email, I will send you the recording. I will also send you some resources, and I will have some links there on comparison between the independent events and mutually exclusive. One thing we have to understand is for mutually exclusive, if one occurs, the other one cannot occur. But for independent events, they can occur, and the probability of one will not affect the probability of another. So they can have something common between them. Does anybody have questions? That actually brings me to the end. So if you want to reach me, my email address is stemcoach@snhu.edu. Yes, I'm coming to that. Best way to schedule a time. So I will send you the link. The link is in here. I will send it to you in the follow-up email. So when you log in, click on the link. You will have to create a login. Please use your SNHU email address. Create a login ID and password. Once you are in there, there is a drop down, so you can look at what tutors or coaches are available. So if you have questions on the statistics part and also on the Python part, I would suggest you booking a session either with me or with one of the IT peer tutors, because we can help you with the statistics and also with the Python code. But if you have questions just on the concept, then feel free to book a session with one of the math coaches. They can help you with the statistical concepts. All right, I will send the link in the follow-up email. So for those of you who want, who have questions on the discussion, feel free to just stay for another couple of minutes. We can take a look at the discussion and see what we need to do for this week.